From the research methods phase, you should remember that reliability is the consistency of a measure, and that validity is the accuracy of a measure. A measure must be reliable to be valid. However, a reliable measure is not always valid. In this video, we're going to talk about reliability. So it's just the consistency of a measure, and particularly of the Likert scale, but just because something is reliable doesn't mean it is valid or accurate. But reliability is kind of the first step in showing validity. One type of reliability you can do is retest reliability. So you have the same group of people take the test or the scale, and then they retake the test after some period of time, and the scores from each time are correlated with each other. So we just do a Pearson correlation on test 1 and test 2, or scale 1 and scale 2, and sometimes the tests are the same, or sometimes they're equivalent forms, but we just correlate them. For example, the retest reliability for the Rosenberg self-esteem scale after 2 weeks is 0.85, and after 7 months is 0.63. So this is just a correlation between the self-esteem scale composite score at time 1 and the self-esteem scale at time 2. And the difference between the times for the first one was 2 weeks, and we got a 0.85, and then they did it again for 7 months, and they got a 0.63 correlation. So the more time in between, the lower the correlation was, and that kind of makes sense, right? Here are some considerations for retest reliability. So some things that might happen when you're trying to get retest reliability. Well, it takes more time and resources to collect test scores twice. So sometimes it's not possible to actually collect them twice. You might not have enough money or time to do it, or maybe a company doesn't want you to collect data twice. They don't see the benefit to collecting it twice. Like, we already let you collect it once, why do you need to collect it twice? It also might be hard to survey the same people again. So especially if you have an anonymous survey. So sometimes you want surveys to be anonymous, so people feel free to be truthful in their survey. So if it's anonymous, then you can't link the two tests together, the two surveys together. So at time 1, if you don't have anything that identifies them, then at time 2, you can't link their new scores together. And you can't do a correlation unless you have your pairs of test scores. So it has to be kind of paired by person, or you can't do this. You can also have carryover effects. So taking the test the first time might influence the second test. For example, ACT scores. So kind of practicing on the first test might help some students and not others. And so some of the scores might increase on the second test while others might not. So if everyone increased the same amount, then you would still have a strong correlation. But if practicing helps some students significantly, because maybe they're not used to doing standardized tests, but it doesn't really help other people because they're just used to doing standardized tests, then the correlation won't be as high because you have these carryover effects. So practicing on the first test might influence some students to do better on the second test, and so your correlation won't be as high because of these carryover effects. Another problem might be that the attribute being tested might just naturally differ over time. For example, self-esteem might lower or raise for some after a big life event. So if you saw on the other slide, the retest reliability for self-esteem was much lower when we had a 7-month period versus the 2-week period. So it seems like over time, self-esteem will differ. Over 2 weeks, it didn't seem as bad, but definitely over 7 months, it could change somewhat. Maybe not for everyone, but for enough people that we saw a lower correlation for the 7-month period than for the 2-month period. So these are all just kind of problems that you can encounter when you're trying to do a retest reliability on a scale. So it might be difficult to do a retest reliability. So an alternative is to do a split half reliability. And you only have to administer the test once, and you correlate half the test with the other half. So for example, you can create a composite score for the odd items of a scale and another composite score for the even items. And then you correlate the two composite scores. So you correlate a score for half of the items with the other half, and you get a correlation. But when you do this, it's not directly comparable to the retest reliability, because what you're doing is you're correlating a composite score for 5 items with another composite score for 5 items, and just naturally the correlation between 5 and 5 is not going to be as large as if you did the test again and did a composite score for 10 items and then did another composite score for 10 items and then correlated them. So a 5-item scale is going to be less reliable than 10 items. But we really want to know the reliability for the whole test, not just half of it. So it kind of creates this problem. We want to know what the reliability is for the whole 10 items and not just the 5 items, because when you split it up in half, you're really just getting the reliability for the 5 items. But in reality, we're going to administer 10 items. To correct for this, 2 researchers simultaneously came up with this correction, and their names were Spearman and Brown, and they made this formula to use the split half correlation as a prediction of what the retest reliability would be. So it's just an estimate of what the retest reliability would be based on the split half correlation, and you don't need to know like how they came up with this formula. They came up with it and they proved it. You just need to kind of understand that we're using the split half correlation, which is the correlation between one half of the test to the other one, as a prediction of what the retest reliability would be. So it kind of increases that correlation by a certain amount to account for the fact that the correlation between half and half of a test will always be lower than the correlation between a whole test and another whole test. So here we have RSBC, and that just stands for the Spearman Brown correlation, or correction, sorry, or correlation. And that equals 2 times the split half correlation divided by 1 plus the split half correlation. So you just plug in the split half correlation in this formula, and you put in your calculator and you'll spit out the corrected correlation. That's an estimate of the retest reliability. Now the 2 here comes from the fact we're kind of doubling the test, or not really doubling the test, but we have like 5 items correlated with 5 items, but we really want to know about the correlation between 10 items and 10 items. They're kind of like doubling it. So that's where the 2 comes from. And you can also use this in another way, this correction, so I'll show you here. So you can also use a Spearman and Brown correction In another way, you can also use a correction to estimate what the reliability would be if you had more items on your test. So you change the 2 to the number of times bigger the test will be. So that's what k is. So k now is the number of times bigger the test will be. And instead of putting the split half reliabilities here, you put your retest reliability. So it's kind of the same concept, right? Before we're doing half and half, so we're kind of doubling the test. So that's why we put it 2. But now we're going to say, okay, what if you really have the retest reliability and you want to estimate what your reliability would be if you made the test longer? So say you want to make the test 3 times longer, then for k you'd put 3. And this is kind of helpful if you have like a short scale and you want to make it longer, but you're not sure how long to make it, and it's not as reliable as you want it to be yet. So you kind of want to make a prediction of how long you should make it, because you don't want to make it too long. So over here on this chart, say the original scale has a reliability of 0.7. Okay? So it's 0.7 here. And you want to have it at 0.9. That's your goal reliability. So you could use this formula to see how many more times bigger you need to make it. So that would be here. And so that means you need to make it 4 times bigger. So say your original scale is only 2 items, then you would need to make it 8 items long because it's 4 times bigger than your original. So this is just another way to use a Spearman and Brown correction. So one concern about this split half correlation was it's not really a good indicator of the retest reliability. It's going to always be smaller. But another thing that came up is how should you split up the test? It's kind of arbitrary. So should you do odd and even? Should you do the first half and the second half, which is probably a bad idea because of fatigue, but there's also a bunch of other ways you can split up the test. So it's kind of arbitrary. So Cronbach came up with this way to do all the split half correlations and then kind of average it out and use that with the Spearman Brown correction to get a prediction of what the retest reliability will be. So we're using all the split half correlations and kind of getting an average of them to use the Spearman Brown correction to get a prediction of the retest reliability. But what he also proved is that instead of using all the split half correlations, we can use the inter-item correlations instead, and that will be the same as if you had all the split half correlations. So the inter-item correlations is just the correlation between 2 items at a time. So an inter-item correlation is the correlation between 2 items at a time. So you correlate all the items with each of them, and then you get the average, and then use the Cronbach's formula to get a prediction of the retest reliability based on all the possible ways you could do split half correlations. And we're going to do that in the next video. We're going to learn how to use the formula. So basically, now you don't have to split up the test in a certain way. We're using all the ways you can split up the test, but we're also using the Spearman Brown correction. And instead of doing split half correlations, now we can do the correlation between 2 items at a time and do it for all of the items and get an average of that. Okay? And we'll do that in the next video.